This is from the vectors chapter, 15H1, example 15, and this is about elementary row operations. So we're stepping out of vectors, as you will, a little bit, because we were going to deal with a matrix method, really, a method of solving which is associated with matrices. And but it works very well for vectors because vectors can be part of a matrix, at least the coefficients there. So let's try to crack this. The thing is that we're going to write this as an augmented matrix. And that implicates that we will detach the coefficients. There we go. Let's see if that works. Yeah, close enough. So how does that work? Well, the coefficients 2, 3 and 4 are going to be written, and so are 5, 4 and 17. We put a bit of a line here, which sort of indicates the equal sign. Let's clean it up a little bit. A little bit better. And because it's a matrix, we will put it in these square brackets. And now it is an augmented matrix. The augmented part is this answer part here. That's why it's an augmented matrix and not just any matrix. And the matrix symbolizes these two equations, but we take out the x and the y's, so we have detached the coefficients. And now it's like solving a system of two equations. And how are we going to do that? Well, the top here we will call row 1, and the bottom there we will call row 2. And we will try to create a 0 there on row 2, preferably here in this corner. So we're going to rewrite row 2. Row 2 is going to be, we say, let's say it's going to be 5 times row 1, take away 2 times row 2. So we are going to replace row 2 by 5 times row 1, take away 2 row 2. And that's an elementary row operation. If we do that, when we do that, the top row does not change because we didn't do any operation on that. But the bottom row will become, well, 5 times 2, take away 2 times 5, 0. 5 times 3, 15, take away 2 times 4, that's 8, 15 take 8, 7. And 5 times 4, 20, take away 2 times 17, which is 34, it's negative 14. So there we have it. Now, I don't even need to go further here, because from this bottom row now, I can now deduct that 7y equals negative 14. Therefore, y equals negative 2. And if I take that result and I will plug it in here, because there's a y there, really, it says 2x take 6 equals 4. Or in other words, 2x is 10, x equals 5. So here are the answers. X equals 5 and y equals negative